Okay, welcome back. After finishing the confidence interval, I want to cover what are some processes of the calculating some the t-test for the two samples. So far, we just compared the two groups. So one group from the population and the sample group based on the sample statistics. So there was the one sample t-test. But now we are setting some different ones, so different time and different item. So within one population, so there are so many groups. So the gender, so based on the biological sex. So we can compare the group of the A, so group of male, let's call it male, and group of B, maybe let's call it, say that is female. So we can compare whether those two groups are statistically different or not. So based on the statistics as the mean of the sample, so mean of the sample number one and mean of sample number two, so we can check that whether those two samples would have the same mean, same sample mean, or statistically different, statistically significantly different mean based on those two groups. So I will show you more example. So again, review, the population parameters are not available mostly, so we are using the T because we are assuming. So we are assuming sometimes that we know the population parameter, but usually we don't know the population parameter, such as population mean and population standard deviation. So that's why we are just using the sample mean and hypothetical. So we just guess. So we just guess that the population mean is there, and minus mu divided by sampling error as the standard deviation of sample divided by squared root number of cases. So you can use calculate that. So based on those 5 steps in the previous video, I showed how to check whether the population mean and sample mean are different from each other. So those samples and those examples you can review because I already uploaded this lecture slide, so you can review later. Anyway, so in summary, in conclusion, single sample mean, so single sample t-test, so one sample t-test, so these are exchangeable. So one sample t-test or single sample t-test. Anyway, we are just checking or comparing whether the sample mean is different from population mean. And the t-statistics. So if you have super high or big enough t-statistic, it means that the population mean and sample mean are very different from each other. And based on based on the critical area, so you might remember the bell curve on the distribution, the bell-shaped distribution, and checking 2 points as positivity critical and negativity critical. So we are shading those two tails, and then we assume that if our t-statistic is inside of those two tails, which means just happening less than 5% or less than 5% by chance. So that will confirm, or that will give us the impression and the confidence that the difference between population mean and sample mean is not happened by chance. So anyway, in summary and in conclusion, we were able to use the single sample mean t-test to compare population mean and sample mean. So that was the basic philosophy of the single sample mean t-test. But now again, so within one population, when we have two groups, so again I stress that two groups. Well, it means that when we have 3 or 4 groups, we cannot use independent sample mean t-test, but we can use only when we have 2 groups. So we are just checking whether those 2 groups would have statistically significantly different mean from each other. So based on those mean as a sample statistic, we are just comparing. So maybe they would have the other differences, but we are just using the mean of those 2 groups and checking whether they are same, whether they are same, because it means that they are same group and they would have the same mean, or they would have a different mean. So steps are very same, but you might realize that there is no effect size calculation. So I skipped that part because that is very complex in the calculation, but we can just keep those 4 steps as a formal process. So in example, so one possible example is the gender inequality in income. So in theory, and also there are so many debates that the gender inequality. So what are the underlying causes, or what are the result or the outcomes, and also what are the reasons of the gender inequality? But it's very easy to see that there are still some sides of the gender inequality in many parts. But income is one measure to calculate and to check or to capture the inequality level. So mean income of the male and mean income of the female. So we can use those two means, I mean average income of a male and average income of a female, to compare them as whether they would have the real difference or just they are identical, but those kind of differences are caused by the sampling error or caused by chance. So we are using those criteria in independent sample t-test. Again, when we have two groups. So when we have 2 groups in sample, we can use independent sample t-test. So setting up the hypothesis, again, they are very cynical. So null hypothesis is very cynical. So this says that there is no difference in 2 means. So again, in our example, there is no difference in mean income by gender. But our alternative hypothesis says there is difference in mean income by gender. So again, if the calculated t-statistic is inside of the 2 tails, the shaded 2 tails, that means that we reject the null hypothesis. Then we can argue that there is difference in mean income of the by gender. But if the t statistic, so later we will calculate the t statistic, but if the number is in between the not in the those 2 tails, but in between, it means that yeah, we can see some difference in those 2 groups in our sample, but that difference is just caused by the sampling error or by chance. So these are 2 divergent points. So reject the null means there is statistically significant mean differences. So separate the 1. They are not. So it means that there is some relationship between gender, in our example, gender and income. So gender and income are not there. So when we reject the null, it means that based on gender, there is the difference in income. But if our test is that based on our conclusion, if we fail to reject the null hypothesis, it means that there is no difference between male and female in terms of the average mean. So it means that they are independent from each other. So they don't care each other, and gender and income, these are not associated. So this is why we call this is as independent sample t-tests. That they are separated, or they are associated or dependent to each other. Setting up. So in terms of the mathematical calculation, H0, which is a null hypothesis, says the mean of the group number, so mean of the group 1 and mean of group 2 are same. So it means that there is no difference. So we can denote this part as M1 minus M2 is 0, because that means that they are same. The alternative hypothesis says that there is difference. So there is no difference in mean income by gender, which is the null hypothesis. Alternative hypothesis says there is difference in mean income by gender. So there is the null hypothesis. And setting up the critical region. So this is a little bit different here. So there is a freedom of the 2 groups. So back in the 1 sample t-test, we just used the calculation as n minus 1, which is the total sample size minus 1. But now we have 2 groups, male and female. So we have two sample size as number of males in our sample and number of females in our sample. So that is the degrees of freedom is calculated as N1. So number of cases of the group number 1 minus 1 and plus number of samples, number of cases in group number 2 minus 1. So that will be the calculation of the process. And let's suppose that we have those numbers. So the average male's income is 45,000 and standard deviation of the male's income is 2,500. And there are 312 males in our sample. So that will be the sample size of male. And in the female, so we have the statistic of the female as the second group. So first group was male and second group is the female. $35,000 as female's mean income, 75,000 as standard deviation of the female's income. So you need to make sure that there are two statistics there. Anyway, standard deviation of the first group as male, standard deviation of the second group as female. And 480 is the sample size of female. So degrees of freedom is calculated as N1, which is number of number of cases in the group number 1, 312 minus 1, plus 480 minus 1. So after calculating those numbers, this is 790. So the degrees of freedom is 790. So now we have the degrees of freedom. What will be our next step? So after having degrees of freedom, so not like z-score, we don't have the fixed number in critical area. So we need to go to the t-table. So you can find it on the Moodle, and if you save it in your folder, maybe you don't need to do that. So we are using 0.05. So if I don't say anything, or usually if I say alpha level is 0.05 and without any specific instruction, we are using 0.05 as alpha level. So we are using this column, and 790 is the degrees of freedom as a row. But as you might see, there is no the matching number. So in this situation, if we cannot find any matching or exactly matched number, we are just using or approaching the closest value. So 790 is closer to 500 compared with infinity. So we are using 1.965 as t-critical. So in this distribution, it is negative 1.965 and this is positive 1.965. So I will show you in the next slide. So after calculating the t-statistic in the next slide, if the calculated t-statistic is in this shaded area. So if the statistic is bigger than 1.965 or smaller than negative 1.965, it means that we reject the null hypothesis. So rejecting the null hypothesis means that there is a statistically significant difference between male's mean income and female's mean income. But if the t-statistic is in between in those parts, it means that probably we can see some difference in the sample mean of the mean income of the male and mean income of the female in our sample. But this kind of difference is caused by chance, not by the relationship between the gender and income. So in that case, in that scenario, when we fail to reject the null hypothesis, we would say that the gender and income, they are independent because they are not related. So that is the criteria we can use. So the calculation is again t equals the M1, which is the mean of the group number 1 minus mean of the group number 2. And the sampling error, SEMI, as I means independent sample t-test. So SEMI is a little bit different from what we had in the one sample t-test because that is the square root standard deviation of the first group squared divided by number of cases of the sample group number 1 plus standard deviation of the second group. So second group square divided by number of cases of the second group. So it's very complex here. So after summing up them, it's transposing that one, t is equal to the difference between those two means divided by sampling error. So at the first glance, it would be very tricky, but after calculating, after repetition, and after using some preset of the Excel file, it will be very helpful. But anyway, I will cover the calculation process in the next example of the Excel. I will show you very soon. But in this time, let's suppose that we already calculated those numbers. So these are the numbers you can plug in. So please make sure. So this part will be very important because these are the example of the putting the numbers. The first group, the mean of the first group here, right? So 45,000 minus 35,000 of the second group divided by square root of the squared standard deviation of the first group and squared standard deviation of the second group divided by number of cases of the first group and the number of cases of the second group. After this calculation, there is 10,000 divided by square root of this number. So after those calculations, we can find that about 26.996. So after rounding off, it's around 27. So our t-statistic is 27 in our calculation. So in the previous step, 1.965, so positive and negative 1.965, those were t-critical. And our t-statistic is inside of those shaded two tails. So 27 is far larger than 1.965. So it means that we can reject the null hypothesis, which means there is statistically significant difference in mean income by gender. So in this conclusion, we can say that the gender and income, they are associated because the gender impacted on the mean income, right? So in this kind of example, we already had those numbers as a sample statistic. But so before going to these sample statistics as steps or the calculation, let's suppose that we need to calculate the mean and standard deviation, and we can find the number of cases surely. So when we don't have those numbers, we need to calculate them by using Excel or by using calculator, but usually by Excel. So I will show you how to use those numbers. So for example, these are some numbers by male and female. So those are numbers, those are the numbers, and by using those numbers as two groups, so we can calculate the t-statistic based on this number. So I will show you how to do it. All right, so let's cut it here, and let's go to the let's see in the next video to show the calculation process of the independent sample t-test by Excel.